first example, it's in page 178, exercise 4. We've got this funky shape. Okay, I'm doing example 6. So I'm just reading a little bit of the data that you have here. ABCD is a parallelogram. Okay, so ABCD is a parallelogram. EH bisect angle ABC. Okay, I hope you remember how to write an angle. Okay, sometimes we don't often do it, but sometimes we do it. If I want to look at this angle, in other words, B1 plus B2, okay, that's angle ABC. So we put the B in the middle with that little hat. You seen it before? Mm-hmm. Okay, cool. So BH bisect angle ABC. Now, I didn't do it deliberately, but I'm actually happy that, I mean, it doesn't, that line BH, it doesn't look like it bisects the angle. Okay? I didn't draw it properly, but that does happen sometimes. Okay, so sometimes you'll get a drawing and it doesn't look like this angle is equal to that angle because they didn't draw it to scale. But you have to just accept it like this, okay? So this angle is equal to that angle. It's a good idea that as we write things, as we read through the data, we just make notes on the drawing, okay? So that angle equal to that. Right, next thing, we told that HC bisect BCD. So HC bisect BCD. So in other words, this angle equal to that angle. Okay? Stop me please if you don't get something. ABC, angle ABC is 60 degrees. So all of that is 60 degrees, meaning B1 will be, so that will be 30 and this one will be 30. Straight away write it on the drawing. And F is 120. I'm going to write 120. Now I'm also told that BH, by the way, this should be G. BH is parallel to GC. So these two are parallel. And BG is parallel to HC. Okay? And what we asked to do is to prove that this shape here is a rectangle. That's what I need to prove. Okay? So, right, where are we going to start? Right. So the first thing I know about shape, what do I know about this shape? If this is parallel to that and this is parallel to that, so what can I say about BGCH? What shape is it? It's a parallelogram. It's a parallelogram. And I need to give the reason. The reason are 2 pairs, or I'll just write it like that. I'll write BG is parallel to HC and BH is parallel to GC. We've got 2 pairs of parallel lines. Okay? We're right? Now, how would I prove that this parallelogram is a rectangle? What do I need to prove is the angle inside? 90. So I need to prove that one of these angles are 90. So you can kind of see already what's happening here. Okay? If this is 60, okay, and we know this is 30 and this is 30, what angle will that be? If this is 60, this will be 120, because these two angles are quaternion. And if this is 120, what will that be? 60. If this is 60, this is 30, that will be 60, 30, that will be 90 degrees. Okay? So we just need to be able to write it. So how are we going to write? We're going to say, okay, we're going to say angle ABC is equal to 60 given. Okay? Therefore, we can say that angle BCD is equal to 120, okay? Because quaternion angles, okay? And I need to write down the 2 lines that are parallel. AB parallel to CD. Okay? And they add to 180. Next thing I know that C1 is equal to C2. That was given. Okay? Because what? You can either write given. It's probably going to be better to say HC bisect AB. C1 is going to be 60. Okay, if they're both equal each other, we can maybe even to make it a little bit more structured, we're going to say that therefore C1 plus C2 is equal 120, therefore C1 is equal to 60. Okay? Now, I'm going to look at B2. B2 equal B1, okay? Because BH bisect A, B, C. And you see, it's one thing about knowing how to solve. It's another thing to actually write the annoying thing. Okay? And I also know that B2 plus B1 is equal to 60. I was given that, yeah? I was given. Therefore, you can still see that, you can. Okay, therefore, B1 or B2, that's what I'm after, is 30 degrees. Okay, so I know this is 30 and I know this is 60. And now I can say, all right, H2 plus B2 plus C1 is equal to 180. What statement must I write here? Sum of angles in a triangle, not trinomial. Okay, so I can say, right, H2 plus 30 plus 60 equal 180, therefore H2 equal 90.
So,
yeah, let me just pause this part. Okay, so we got H2 is 90 degrees, and then we can say that, okay, BHCG is a square, not square, rectangle. And the reason, I'm not going to write it down, the reason is that it's a parallelogram with an interior angle of 90 degrees. That's what we got to say. It's basically a parallelogram with an interior angle of 90 degrees. Now, Aaron very correctly here realized that we can do it slightly different. So once we know this is 60 and this is 30, I can go another way. Instead of H2, I can look at C4. This is 30, C4 is also going to be 30. These are alternating angle, where these are parallel lines. And if this is 30 and this is 60, then this angle, HCG, is 90 degrees. And then again, we can say it's a rectangle because that's also an interior angle. So I think all of you guys get it, but the question is if you write the whole thing. Okay? So I'll just pause here, let you write it down if you want to, and then we'll move on to the next part. So in part B, we want to show that this shape, DEFC, is a rhombus. Rhombus is a parallelogram where adjacent sides, all the sides are really equal. So the first step, and that's often the case, it was the same in A, we want to show first of all that it's a parallelogram. Now how would I know that it's a parallelogram? Okay. I'm going to look at lines that needs to be parallel. So I know, right down purple, we already spoke about it in the first part, but this is 120. Now I know this is 120, so I've got to write F is equal to 120, given. C1 plus C2 is also equal to 120. It wasn't given, we proved it in the first part. So if we proved something earlier, just say prove. So these two angles are equal. What does it tell you?
336. Oh, they parallel.
That these lines are parallel, okay? So what we're going to say is line EF, not equal, is parallel to CD. And what is the reason? Do you remember what the reason we write?
No.
No. So what do we call these angles? Corresponding. If we knew that these two lines are parallel, then we would know they're equal. Now, we're doing the converse. We don't know that these lines are parallel, but we know that these corresponding angles are equal. If the corresponding angles are equal, then the lines are parallel. So what we got to write is corresponding angles equal. Okay? If these two corresponding angles are equal, that means that these two lines are parallel. So we got one pair of the parallelogram. The next lines that we need to prove are parallel are CF and D and E. But we know that AD is parallel to BC. Right? We know this line is parallel to that because ABCD is a parallelogram. Okay? Obviously opposite sides are parallel. Now DE and CF are extension. Yeah, you can just say it. I mean, I'll use their word. Let me just pause here for a second. Okay. Yeah, so what you can say, so what the words they're using here is ADE and BCF. We say that instead of extension, they use the word straight line. I think that's probably good. Yeah, it is good. Straight lines. They're straight lines. Now, if they're straight line, therefore, DE is parallel to CF. Okay. So we've got two pairs of parallel line. So what we get is DE if C is a parallel line. Okay? And to be on the safe side, you can say, oh, well, two pairs of parallel lines, two pair of lines are parallel to each other. Now, I need to show that these adjacent sides are equal. Well, it's very, very easy, isn't it? I'm told that DE is equal 30. That was a given in the beginning. Okay? Now, I want to show that this is 30. How can I prove that DC is 30 as well? Okay? I know that AB is 30. Okay? I know that AB is 30. That's a given. That's it. So if AB is equal to 30, DC is also equal to 30 because it's equal to AB. Okay? And we call it opposite side in parallelogram. Now I'll move up to here. So therefore we have BC equal to DE, and therefore DECF is a rhombus. I'm not spelling it right. Rhombus, okay? And the reason is that you have adjacent sides equal. A lot. I'm just going to pause here for a second. Okay? So Luke is asking, so you showed that these two sides are equal. Shouldn't we also show that these two sides are equal? Now, if you want to be very, very careful, you can say, okay, if this is 30, okay, so these two are equal, but also this is 30. Because this is a parallelogram. So, and if this is 30, this is also 30. So they're all 30. So therefore, the line, what we need to remember is that as soon as you've got two adjacent sides, just two, equal, it's a rhombus. Okay, it's a long, I know it's a long, and there's lots of details. Yeah, geometry is not fun, for me anyway, but some people love it. Guys, let's have a quick break, and we'll move on later.